I'm Bob Tisdale. Welcome back to Part 2 of the natural warming of the global oceans. In Part 1, we introduced the processes associated with El Niño and La Niña. We also illustrated and discussed how El Niño and La Niña events were the primary causes of the warming of global sea surface temperatures during the satellite era, which is the last 30 years. The two discussions are so interrelated, so dependent on one another, that you can't discuss the warming of the global sea surface temperature without discussing the processes of ENSO. And you can't discuss the processes of ENSO without showing how they have caused the warming of global sea surface temperatures over the past 30 years. The next topic of discussion is the impact of ENSO and other natural variables on ocean heat content. Ocean heat content, as noted in Part 1, is in part a measure of the temperature of the oceans to depths of 700 meters or about 2,300 feet. The saltiness or salinity of the water impacts how much heat it can hold, so it too is measured and included in the data set. Therefore, ocean heat content is presented in joules, not in degrees Celsius. You might be wondering why we're discussing ocean heat content after we showed that satellite-based sea surface temperature records for the past 30 years showed the oceans warmed naturally. There's a very simple explanation. Proponents of anthropogenic global warming try to downplay the importance of that finding in sea surface temperature data by redirecting the topic of discussion to another data set, ocean heat content. They then claim that ENSO cannot explain the warming of ocean heat content data, but we've already shown and presented that they're wrong. That is, in Part 1 of this video series, we also discussed and illustrated the impacts of El Niño and La Niña on ocean heat content for the tropical Pacific and their interrelationships. Again, you can't discuss one without the other. Anyone who understood ENSO should not have been surprised to see that La Niña events were the primary causes of the warming of the ocean heat content data for the tropical Pacific. We showed how the freakish 1995-96 La Niña provided the warm water for the 1997-98 El Niño, which was the strongest El Niño of the 20th century. It was that El Niño that effectively shifted up the sea surface temperature anomalies for 67% of the global oceans by about 19/100ths of a degree Celsius, almost 0.2 of a degree. However, it was the 1995-96 La Niña that basically shifted up the ocean heat content for the tropical Pacific and supplied the warm water for that El Niño. Prior to that event, the primary causes of the warming of the ocean heat content for the tropical Pacific were the 3-year La Niña events of 1954 through 1957 and 1973 through 1976. The other 3-year La Niña since the start of the ocean heat content dataset was the 1998 through 2001 La Niña, which recharged the heat released by the 1997-98 El Niño and replenished the warm water that was redistributed in the wake of that El Niño. Let's look only at the impacts of the 3-year La Niña events to start. During the multi-decadal periods between those 3-year La Niñas, ocean heat content cooled in the tropical Pacific. That's shown by the negative trends. That is, there is no anthropogenic carbon dioxide-driven global warming signal in the ocean heat content data for the tropical Pacific between those 3-year La Niña events. None. We also showed how the 1995-96 La Niña skewed the trend of the middle period between from 1976 to 1998. If we eliminate its impact, the trend for that period drops considerably and falls into line with the others. Again, there's no anthropogenic global warming signal from greenhouse gases. In Part 1, we discussed the processes Mother Nature employs to recharge the heat released by an El Niño and to replenish the warm water that has been redistributed away from the tropical Pacific in the wake of those big El Nino events. I'll borrow a short clip from Part 1 as a refresher for you.
La Niña conditions are next. They're simply exaggerated enso-neutral conditions, but they play an important part in the enso process. The trade winds are stronger during a La Niña. This causes more cool water in the east to be upwelled, so the cold tongue extends farther to the west than normal. And the stronger trade winds push the West Pacific warm pool farther to the west. With a warm pool farther to the west and with the stronger trade winds, there's less cloud cover over the tropical Pacific. This allows more sunlight, known in scientific terms as downward shortwave radiation, to enter the tropical Pacific and warm it to depths reaching 100 meters, though most of the warming takes place closer to the surface. The additional sunlight provides more warming than normal to depths of the tropical Pacific Ocean. This allows the La Niña to replenish the heat that was emitted by the El Nino and to replenish the warm water that was released by the El Nino and redistributed in its wake. Most times, as shown in the top cell, the La Niña replenishes less warm water than was released by the El Nino. At other times, a La Niña can cause more warm water to be created than was released by the preceding El Nino.
Also in Part 1 of this video, we expanded the discussion to the tropics as a whole. And if you'll recall, the tropics represent about 40% of the surface area of the global oceans. The ocean heat content data for the tropics showed similar results. That is, they cool between the 3-year La Niña events. Also, like the tropical Pacific, the 1995-96 La Niña skews the tropical trend. Without it, the tropical ocean heat content shows significant cooling between the major La Niña events. Because the tropical ocean heat content shows a long-term warming, and because the tropical data cools between the major La Niña events, and because the tropical ocean heat content only warms during the major La Niña events, then one might conclude the 3 major La Niña events of 1954 through 1957 and 1973 through 76 and 1995-96 were responsible for the warming of the tropical oceans to depths of 700 meters. Before we look at the data for the other portions of the global oceans, let's discuss the numerous problems with the data set. Here's a graph of the National Oceanographic Data Center's, the NODC's, ocean heat content data for the top 700 meters of the global oceans. The data is available from 1955 to present. The NODC has done a masterful job of collecting temperature and salinity measurements in order to create this data set. But there are a number of problems with it. First, it's portrayed as being global. If we recall our sea surface temperature data set, the Reynolds Optimum Interpolation version 2 data, it's a satellite-based data set, and there were actual measurements taken daily from the Antarctic to Arctic ice caps over the past 30 years, since the satellites were deployed. It's a data set in which we can have a reasonable amount of confidence. But that's not the case for the NODC's ocean heat content data. Here's a map from the NODC's website that shows the locations of the temperature measurements at the depths of 500 meters. The data set is for the top 700 meters, so we're well within the range. The map covers the first quarter of 1955. That's the start of the data set. Note how sparse the measurements are. Each of the little black dots represents one temperature measurement over a 90-day period. One temperature measurement for 3 months. The green dots are locations with 2 to 5 samples. Again, over a 90-day period. Let me start an animation that shows the locations of the readings for each 90-day period from 1955 to present. As you'll note, most of the temperature readings were in the northern hemisphere and in the tropics. Complete coverage does not happen until the mid-2000s. So all of the data before the 2000s is spatially incomplete. Let me correct that. Because depth is involved, it's volumetrically incomplete. That is, they do not capture the oceans globally to depth. Note also that the locations are random. The measurements are random. They're constantly changing. Additionally, coverage improves for a while and then it slacks off. Notice how the numbers drop in the 1990s until the Argo floats were deployed. Here's the drop in the 1990s. And now you can see the deployment of the Argo floats. For those who aren't familiar with the Argo project, the floats are described in the following video from the University of California, San Diego.
Scientists on research ships can sample the ocean only briefly, so they deploy automated devices for long-term ocean monitoring. This float is part of an international research program called Argo. It measures ocean conditions that drive events such as El Niños and climate change. Like a hot air balloon, it drifts along on slow-moving currents in the deep sea. The float dives by mechanically decreasing its volume in the water, and it descends to as far as 2 kilometers, more than a mile, to survey otherwise unmeasured underwater regions. Submerged for up to 10 days, the float can be programmed to stay at one depth or to move up and down to follow changing conditions. At preset intervals, it ascends by increasing its volume. Rising through many ocean layers, it records the ocean pressure, temperature, and salinity, collecting an up-to-date profile of evolving ocean conditions. At the surface, the float makes radio contact. Its new location reveals the features of underwater currents, and the data supply real-time measurements of subsurface ocean conditions, details unavailable without Argo. After a short period, the float is ready for another cycle, a process that can repeat for more than 5 years. With 3,000 floats in a global network, the Argo program will supply real-time ocean data for immediate use in research and operational forecasting of marine and climate conditions worldwide. Argo, observing the oceans in real time.
Did you catch their moment of frankness, of honesty, of truth? After the float splashes into the water, they state, "This float is part of an international research program called Argo. It measures ocean conditions that drive events such as El Niños and climate change." Here, listen again.
This float is part of an international research program called Argo. It measures ocean conditions that drive events such as El Niños and climate change. Like a hot air balloon, it drifts along on slow-moving currents in the deep sea.
Ocean conditions drive climate change. They were being honest. A little history of Argo. On July 18, 2000, Raymond Schmidt of the Woods Hole Oceanographic Institute testified before the Senate Committee on Commerce, Science, and Transportation about the ocean's role in climate. Among other things, he was looking for funding for the Argo program. His testimony included Observing deficiencies. While we have in place a system for monitoring El Niño, we have no such ability to observe the motions of thermal anomalies in the mid and high latitude oceans. Nor do we monitor the salt content of ocean currents to determine the potential for deep convection or to help understand the vast water cycle over the oceans. But new technology, the vertically profiling Argo float, promises to give us the data we need to begin to understand this largest component of the global water cycle. These are like weather balloons for the ocean, drifting at depth for 10 days and then rising to the surface to report profiles of temperature and salinity to a satellite. Based on the animation of measurement locations, Dr. Schmidt was very realistic about his portrayal of the observation deficiencies with his statement, "We have no ability to observe the motions of thermal anomalies in the mid to high latitude oceans." There's little to no data available before the Argo era, which began to have reasonably complete global coverage around 2003-2004. Yet people look at a graph of the global ocean heat content and assume it represents the global oceans before 2003-2004. It doesn't. They believe it provides a reasonable representation of the ocean heat content for depths of 0 to 700 meters for all of the global oceans. It doesn't. It's far from it. In other words, anyone who thinks this is a global data set before the Argo era is kidding themselves. No, I'm not faulting the NODC. They collected millions and millions of temperature measurements. But to accept this as a global data set is somewhat of a reach. It's foolhardy, in fact.
The units in the graph are joules times 10 to the 22nd power. Based on the linear trend calculated by Excel, the heat content of the global ocean warmed about 15 times 10 to the 22nd joules from 1955 to present. That's an astronomically high number, a 15 with 22 zeros after it. And rightly so. The thermal capacity of the oceans is about 1,100 times the capacity of the atmosphere. But still, that number with 22 zeros is tough to imagine. In fact, the number is so big that it makes it look as though it's easy to measure, and that's nonsense. Let's put that into terms we can understand. The National Oceanographic Data Center is the keeper and creator of the ocean heat content data. One of the recent papers by that group is the 2009 paper Levitas et al. and others, and the title of the paper is Global Ocean Heat Content 1955 to 2008 in light of recently revealed instrumentation problems. That was a paper that corrected out a hump in the data from the early 1970s to the early 1980s, and they also corrected out the cooling that was taking place during the Argo era, but more on those topics later. In their Table 1, they list the rise in temperature for the global oceans from near the minimum in 1969 to near its maximum in 2008 as being 168 one-thousandths of a degree Celsius. Keep in mind that's for the depths of 0 to 700 meters. That's an awfully small number for such a huge volume of water. Does anyone really think we can measure the temperature of the global oceans to within 168 one-thousandths of a degree Celsius, let alone a change that small over a 40-year time period, when there's very little coverage of the global oceans before the Argo era? Again, let me quote a portion of Dr. Schmidt's statement from 2000. When he gave that testimony before Congress. We have no such ability to observe the motions of thermal anomalies
in the mid and high latitude oceans. Now let's look at the corrections made by the NODC. Some of you may think of them as modifications or tweaks. This is a graph of the UK Met Office's EN3 ocean heat content data. Before 2003, it's made up of an earlier version, the 2005 version, of the NODC's ocean heat content data for 0 to 700 meters. And it includes Argo-era data spliced onto the end. According to climate scientists, there were a couple of problems with the data. Climate models, which are driven by greenhouse gases and not ocean processes, could not reproduce the hump in the 70s and 80s. Also, in recent years, the Argo floats were showing cooling as soon as they were fully deployed and had accumulated a couple of years of data. But climate models and sea level data say the warming should have been continuing. In response to lots of studies that blame the measuring devices, the NODC made corrections to the data. The hump disappeared, and the warming in recent years now continues, though it's at a rate that's still less than the climate models project. The big question, though, were the corrections actually required? Many people thought natural variables could have explained the hump. For example, let's take a look at the ocean heat content data for the North Pacific north of the tropics. We're looking at this region to get away from the direct effects of El Niño and La Niña events in the tropical Pacific. Wind patterns are one of the major contributing factors to how the North Pacific warms to depths of 700 meters. Wind patterns are reflected in changes in sea level pressure. Looking at the hump, the rise in the 1970s could be explained as a change in wind patterns that resisted the northward transport of warm water from the tropics to higher latitudes, where it could be radiated to space easier. If the winds were resisting the northward transport, the warm water would accumulate at depth in the western Pacific in the extratropics there. And the drop in the 1980s could be explained by a change in wind patterns that aided the northward transport of warm water, again so it could be radiated to space more readily at higher latitudes. To many people, it would appear that the hump clearly shows that Mother Nature played the dominant role in the warming of the North Pacific to depths of 700 meters. That is, the hump, which could have been caused by natural variables, was deleted by climate scientists through, quote, corrections, end quote. The corrections, the modifications, the tweaking, what have you, created another problem for climate scientists. The revised ocean heat content data for the North Pacific now cools until the late 1980s. How do you suppose greenhouse gases explain that? They can't. Notice also how the vast majority of the warming in the North Pacific took place over a 2-year period. Those graphs were from a recent blog post. I'm going to switch the graphs from my book. They have slightly different coordinates for the North Pacific. The lower latitude is now 24 degrees north instead of 20 degrees north. The minor change of coordinates makes no difference to this presentation. As you can see, from 1955 to 1988, ocean heat content for the North Pacific cooled. Then abruptly, there was a warming surge that created an upward shift, and that shift can't be explained by greenhouse gases. No way. Now I'll show you something that should be pretty obvious. The North Pacific data would have cooled over the entire term of the data from 1955 to present if it wasn't for that 2-year rise. A 2-year rise that can be explained by changes in wind patterns but can't be explained by greenhouse gases. In other words, there's no evidence of an anthropogenic global warming signal in any of the ocean heat content data subsets for the depths of 0 to 700 meters that we've examined so far. And really, that's all you can do with this data set. You can divide it into logical, reasonably large subsets, and look at the multi-year and multi-decadal changes to see what caused the variations, to see what caused it to warm. Now, the last of the ocean basins for which there was a reasonable amount of sporadic data prior to the Argo era is the North Atlantic. And as we can see in this comparison graph, the ocean heat content for the North Atlantic warmed at a rate that was considerably higher than that of the global oceans. In that respect, the ocean heat content for the North Atlantic is similar to the North Atlantic sea surface temperatures, which have a mode of natural variability called the Atlantic multidecadal oscillation, and it causes the temperatures in the North Atlantic to vary either at a much greater rate than the global oceans or at a lesser rate than the global oceans, and it does it over multidecadal periods. Now we're going to discuss a paper. Lozier and others, et al., 2008, is a scientific paper that made an effort to explain the natural warming of the ocean heat content for the North Atlantic. The title of the paper is The Spatial Pattern and Mechanisms of Heat Content Change in the North Atlantic. The paper was basically a study of the effects of sea level pressure in the form of the North Atlantic Oscillation on ocean heat content for the North Atlantic, and again they were using the depths of 0 to 700 meters. Towards the end of the paper, Lozier and others conclude, thus we suggest that the large-scale decadal changes in wind and buoyancy forcing associated with the North Atlantic Oscillation is primarily responsible for the ocean heat content changes in the North Atlantic over the past 50 years. As you'll note, they didn't say the warming above and beyond the warming of the global oceans. They're suggesting that all of the variations were natural. Now here's the best part. They used the older version of the data set with the hump. Once again, it looks as though the climate science community may have modified the ocean heat content data so that it better matches their climate models, and by doing so, they've eliminated the parts of the data that show Mother Nature is responsible for the warming. After I run through that explanation of the natural warming of the global oceans to depths of 700 meters, proponents of anthropogenic global warming then point to the recently released NODC ocean heat content data for depths of 0 to 2,000 meters. And they repeat their nonsensical statement that natural variables can't explain the warming to depths of 2,000 meters. You're probably scratching your heads in disbelief. We've discussed how there is no anthropogenic global warming signal in the sea surface temperature data, and we've discussed that it does not appear in the ocean heat content data for the top 700 meters. But somehow, proponents of anthropogenic global warming think the impacts of greenhouse gases will somehow bypass the surface and the top 700 meters and warm the oceans from 700 to 2,000 meters. Let's take a look at the temperature measurement locations for the ocean heat content data at the depths of 1,500 meters. That's well within the 2,000 meter depth range of the data set, and it's also much deeper than the 700 meter limit of the other data set. This map presents the locations of the temperature measurements at that depth of 1,500 meters for the first quarter of 1955, and that's the start of the data. There are about a dozen or so temperature samples at 1,500 meters. It's not going to get much better until the Argo era. Here, let's start the animation. I'll give my voice a break for a minute or so and just let the animation play through. And now you can see the deployment of the Argo floats. The data is so sparse at depths below 700 meters, the NODC has grouped the measurements into 5-year blocks. Here's the NODC's map showing the locations of the temperature measurements at 1,500 meters for the first 5 years of data. Each one of those black dots represents one, that's right, only one temperature measurement during that 5-year window. Think of all the processes that can cause major changes in ocean heat content in a year or two. Examples: the 1995-96 La Niña in the tropical Pacific and in the tropics. And then there's that upward shift in the North Pacific. It occurred over a 2-year period. Using those 5-year blocks, they're in effect smoothing the data with a 5-year filter. And that makes the ocean heat content data to 0 to 2,000 meters basically useless in an attribution study. Here, let's examine the effect 5-year smoothing can have. The natural ocean processes with the greatest influence on sea surface temperature and on ocean heat content are associated with El Niño and La Niña events. Here's a graph of the sea surface temperature data for the Niño 3.4 region. As you'll recall, it's a commonly used index for the strength, timing, and duration of El Niño and La Niña events. In fact, in Part 1, we used it as an indicator for the timing of ENSO events. Look at what happens if we smooth that data with a 5-year filter. The El Niño and La Niña events disappear. They're gone. As we've seen, the NODC's ocean heat content before the Argo era for depths of between 700 to 2,000 meters is based on little to no actual measurements. It's a make-believe, a fantasy data set. It's also smoothed with a 5-year filter, so it's very difficult, if not impossible, to use it in an attribution study. What value does it have? It shows the oceans have warmed. That's all it does. Then there's the Argo era. It seems as though not a year goes by without some correction being made to the Argo era data. Are you aware that the Argo era data for 0 to 2,000 meters shows no warming since around 2003-2004 without the corrections? No warming, none, not a zip. In other words, the Argo data has to be adjusted, modified, tweaked in order for it to show warming. Apparently, Argo was not meeting the expectations of the climate scientists in many ways. Maybe, if we can have 3 to 4 decades of Argo data without the constant tweaking, the data set might have some value. Right now, it doesn't look to have much value at all. One last note about the NODC's ocean heat content data. I've mentioned a few times that the 0 to 2,000 meter data before the Argo era is only available as a smoothed data set. I've said that it's smoothed with a 5-year filter. In reality, the NODC does not use a 5-year running average of their annual data. They describe the data in their paper as, here we present estimates for the upper 2,000 meters of the world ocean with the additional historical and modern data using running pentatile 5-year temperature analyses. What's the difference? Well, the 5-year temperature analysis provides a higher linear trend than a standard 5-year running mean of the annual data. What, you say? Yep. Here's a graph of the NODC's ocean heat content data for 0 to 700 meters. It's presented on an annual basis. A 5-year running average is shown in darker blue. The trends are basically the same. Now let's get rid of the annual data. The 5-year running average filter smooths out the year-to-year variations. Now let's add the NODC's running pentadal, however you pronounce it, 5-year analysis data for 0 to 700 meters. It somehow has a higher linear trend, about 15% higher. That's a significant increase from what we have to assume is the same source data. How did they do that? I don't know. I didn't find an explanation in the corresponding paper. And since I really don't consider this data set to have much value, I'm not going to spend a lot of time analyzing it. Closing. As noted in the introduction, proponents of anthropogenic global warming rely on the general public's lack of understanding of the natural processes through which the oceans warm. They would have preferred, of course, that everyone remained unaware of those processes, those natural processes. Hopefully, now you'll have a better understanding of those processes. And hopefully, you were as amazed as I was at how obvious it is that the warming of sea surface temperatures and ocean heat content occurred naturally. Since the sea surface temperature and ocean heat content records show no evidence of any anthropogenic influence, what effect does the additional infrared radiation from man-made greenhouse gases have on the oceans? Because infrared radiation only penetrates the top few millimeters of the global oceans, it simply adds to the natural evaporation, as physicists and oceanographers have been saying all along. Everything presented in this video was discussed and documented with data in much more detail in my book, Who Turned On the Heat? The Unsuspected Global Warming Culprit, El Niño's Southern Oscillation. A general overview of the book was provided in my blog post, Everything You Ever Wanted to Know About El Niño and La Niña. It includes a link to the free preview and a link so you can purchase a copy if this video has sparked your interest. Y'all have a nice day.